Hello, my name is Karush Pernazar. I'm a game engine developer and an overall 3D generalist. I focus on 3D scanning and volumetric video recording, which are different approaches to 3D recording real-world objects. I utilize game engine and 3D scanning to build virtual environments, oftentimes for pre-visualizations, sometimes for virtual art department builds for the final pixel or for LED volume production. What I'm going to walk you through is 3D scanning today and some of the assets that I've created and some of the workflows that I employ to create those assets. I'm not going to go into too much technical detail here. It's more to just walk you through what it takes to create a 3D asset. The first technique in my arsenal of 3D scanning workflows is photogrammetry. Photogrammetry is the process of taking a series of photos in sequential order. A combination of ground photography and drone photography is used for large environments and large structures like the one you see here. That data set is then entered into a photogrammetry software where the images are processed and aligned. It will generate a 3D model that is textured using the pixels from the original photos taken. Here you can see all the ground photos and all the drone photography aligned together. The alignment of all photos allows the software to extract three-dimensional data from the images. Usually when I take a photogrammetry scan, afterwards there's a requirement to clean it up because oftentimes it is being used as a final asset. The scans you're looking at right now were from a TV show set at the Warner Brothers backlot. A portion of the set was cleaned up here and brought into Unreal Engine for some virtual production use case. This room you're seeing now was scanned using photogrammetry. The client required us to clean it up extensively as a final asset. Here it is after the post-production cleanup. This is a combination of cleaning up the mesh, the textures, as well as optimizing it for use inside of a game engine. I often use photogrammetry as a technique for 3D scanning environments. Due to its small hardware footprint, it is very versatile to operate on location. However, trying to scan a moving object or a living object like a human being or an animal will require a special photogrammetry rig where you can take all the photos instantaneously, which means you would have to have enough cameras for every photo you want to take, oftentimes between 150 to 300 different cameras. The photogrammetry rig that you're looking at now was one that we calibrated with 250 cameras. Certain objects and environments are not optimal for utilizing photogrammetry. Sometimes, depending on the physical size of a space, like a soccer stadium, utilizing a drone LiDAR scanner and a terrestrial, meaning a ground-based, tripod-based LiDAR scanner is the best practice. However, LiDAR scanners will give you really good geometry, but will not give you very good textures. For best results, I combine a LiDAR scanner with a photogrammetry dataset, so I get the best of both worlds. However, this is much more time-consuming and can raise the cost for production. There are also LiDAR scanners in mobile devices like the iPhone. These can be used on location during a scout. The quality of these scans is sufficient for pre-visualization. However, it would require extensive cleanup to be able to use a scan from an iPhone as a final asset. This example here is an actual cave where a production was going to film. During the scout, I was able to very quickly scan it and bring it into Unreal Engine to build this virtual environment. This allowed the filmmakers to art direct, set design, and pick out their shots with incredible accuracy. For objects that have fine detail or have translucent surfaces, the best tool to use is a handheld laser scanner seen here. This one's made by Creoform. Similar to LiDAR, it produces fantastic geometry. However, it does not produce the best quality textures. A photogrammetry dataset combined with a handheld laser scan will produce the best results. The next technique is NeRF and Gaussian splatting. NeRF stands for Neural Radiance Field. I won't get into the technicalities of it, but basically you can use a video to generate a 3D model. The video has to be of a particular resolution, but it can be filmed with a mobile device or a professional camera. In the example you're looking at, this is the entrance of a mosque. The video on the left is the original source video shot on an iPhone 12 Pro. The one on the right is a render out of Luma AI, where it's generated a 3D model using Gaussian splatting technique. technique. The 3D model generated by Luma can be imported into Unreal Engine and can be used as an asset. However, this is really in the quality for pre-visualization. Anything that's going to be used for final pixel will require extensive cleanup. We can scan any object using NeRFs or Gaussian splatting, but given its capabilities within scanning vehicles, it is one of my go-to workflows for scanning shiny, large objects. Shiny surfaces are not optimal for photogrammetry. They usually require some sort of laser or LiDAR scanner. 3D scanning vehicles is a very difficult process for photogrammetry and LiDAR, often requiring a lot of preparation as well as a lot of post-production cleanup. Here you can see some examples of vehicles that were scanned utilizing a 30-second iPhone video as the original source material. NeRFs and Gaussian splatting are fantastic tools to be used on location during a scout. The last technique I want to showcase here is a technique, I call it aggregated 3D scanning. I gotta look for a new name. What that means is the models you see here are all generated without any actual scanning on location. Sometimes there are 3D models that I need to generate that are not accessible for me to scan, usually due to the logistics of acquiring a permit and physically going to the location, and sometimes given the physical size of the location, which will require me to go on a scavenger hunt online to get different data sets from videos, drone videos, and still images, collating them, color correcting them to match, and then generating a 3D model. And some Google Earth imagery as well that was utilized here. The set you're looking at was a pre-visualization set created for the show Waco Aftermath on Showtime, where they were trying to measure the actual Oklahoma City building that was in Oklahoma City bombing, but on the actual location in New Mexico where they were going to film. So what you're seeing here is a computer-generated model that's accurate to size of the Oklahoma City building, laid inside of the environment where they're actually going to shoot it. This is for them to be able to figure out their shots and how much visual effects they need for set extension. Thank you for taking the time to watch this video. If you have any further questions, feel free to email me, or you can also visit my social media at PIRCO-ONE and take a look at some of the other work that I've done, and you can also connect with me there. Thank you.